Okay, thank you very much for joining in the class. Today is our fourth lecture, and today we will discuss about buffer solutions. Okay, do you know what is buffer?
Sir, buffer solution is something that stays constant in its pH, or like it stays constant in its pH no matter what you add in it.
Okay, the pH will be constant if we add a small amount of acid or base, right?
Yes, sir.
Okay, so that means we have some preliminary idea about buffer solution. So yes, in the intermediate we discussed about buffer solution, but not in that detail. So today we'll try to understand bit detail. Okay, and if you face any difficulties in understanding, then raise your hand. Okay, I will try to solve it. Clear?
Yes, sir.
Okay, so first of all, what is buffer solution? You are seeing the screen, right?
Yes, sir.
Okay, thank you. Okay, so buffer solution is a solution that actually maintain the pH fairly constant even if you are adding a small amount of acid or base. Clear?
Yes, sir.
Okay, so that means buffer solution resist change of the pH. বাংলা যদি বলি তাহলে বাফার সলিউশন পিএইচ এর যে চেঞ্জ সেটাকে বাধাগ্রস্ত করবে। ক্লিয়ার?
Yes, sir.
Okay, actually if you add a small amount of acid or base, the pH of the buffer solution change very little. For example, suppose a buffer solution pH is 7.05, so if you are adding like a small amount of acid or base, it may be like 7.04 or 7.06, not that much, right?
Yes, sir.
So that means even if we are adding a small amount of acid or bases, the buffer solution pH is fairly constant. Clear?
Yes, sir.
And the power that maintain the buffer to resist the change of the pH, that is called buffering capacity. Clear?
Yes, sir.
So the buffering capacity is the ability of the buffer to resist change of the pH. Okay, is it clear to all?
Yes, sir.
Okay, so who can explain what is buffer solution? Any one of you who can explain?
Sir, I can.
Okay, please try.
Sir, a buffer is a solution which resists the change in pH even after a small amount of acid or base is added.
Okay, good. Then what is buffering capacity?
Sir, try to simulate. It is the ability to resist the change in pH.
Okay, the ability of the buffer to resist the change of the pH. Okay, so that is buffering capacity. Clear?
Mhm.
Clear to all?
Yes, sir.
Okay, so now the type of the buffer solution. So buffer solution can be classified into two types mainly: acidic buffer and alkaline buffer or basic buffer. Okay, clear? Two types.
Yes, sir.
Okay, so as it is acidic buffer, that means the pH will be below 7, and as it is alkaline buffer, so the pH will be above the 7. Okay, clear? The buffer pH.
Yes.
Okay, so now look into the composition. So in the acidic buffer there will be an acid, okay, and its corresponding salt. Clear? So mainly in the acidic buffer the acid is weaker and its salt is stronger. Okay, so as it is weaker, it will not dissociate 100%, but as it is stronger, it will dissociate 100%. Is this concept clear?
স্যার আমি
No.
লাস্টটুকু
Sir,
বুঝতে
can you
পারিনি
please
স্যার, ক্যান ইউ
repeat?
প্লিজ রিপিট?
আচ্ছা আচ্ছা ঠিক আছে, আমি আরেকবার রিপিট করতেছি। ওকে, so in acidic buffer there will be two component actually. Okay, first of all an acid and then its corresponding salt. Okay, so for example here we can see an acidic buffer composition. Here we can see the acidic acid is the acid. Okay, this is the acidic acid, and sodium acetate is its salt. Clear? Okay,
ইয়েস স্যার।
okay, so the acidic acid is actually a weaker acid. Okay, and sodium acetate is stronger, so that means it will dissociate 100%. Sodium acetate will dissociate 100%, but acetic acid will not dissociate 100%. Okay, as it is a weaker acid. Clear now?
স্যার আমি না একটা জিনিস একটু ভুলে গেছি,
Okay,
কোন অ্যাসিডটা স্ট্রং বেশি আর কোনটা উইক এটা জানি কিভাবে ডিফাইন করে?
okay, acha. So the acid that is stronger, it will dissociate to give 100% proton. Okay, okay, so look at the whiteboard. Okay, so suppose HCl. HCl is a stronger acid, right?
রাইট।
Okay, so if you put HCl, it will dissociate 100%. That means, like, if you put here 2 HCl, you will get here 2 proton. Okay, if it is 20, you will get 20. If you put here 20 million, here it will be 20 million proton. Okay, almost 20 million proton. Clear?
ক্লিয়ার স্যার।
Okay, so that means it is dissociated 100%. But if you put acetic acid, it will not dissociate 100%. Okay, so suppose you are putting here 100 acetic acid, say. Okay, you may get here like 5 proton. Okay, so that means it is not dissociating 100%. Clear?
ক্লিয়ার স্যার।
Okay, but its corresponding salt, that is sodium acetate, it is stronger. So stronger means it will dissociate 100%. Okay,
ওকে স্যার।
so here it will get this ion and this plus ion. Clear?
ক্লিয়ার।
So same here as well. A basic buffer will contain a base and its corresponding salt. Okay, so we know that ammonium hydroxide is a base, right? Ammonium hydroxide.
Yes, sir.
Okay, so this alkaline buffer, for example, it contained ammonium hydroxide as base and ammonium chloride its corresponding salt. Okay, clear now?
Yes, sir.
Do you have any confusion regarding the composition here? Acidic buffer, basic buffer composition?
স্যার বেসিক বাফারটা আরেকবার একটু এক্সপ্লেইন করবেন?
Okay, so like acidic buffer, in basic buffer there will be a base. Okay, and its corresponding salt. Clear?
ক্লিয়ার স্যার।
Okay, so here the base may be, for example, here the base is ammonium hydroxide. Okay, and its corresponding salt is ammonium chloride. Clear? So so like acidic buffer, here the base is weaker. So as the base is weaker, that means it will not dissociate 100%, but its corresponding salt is stronger, so that is, it will dissociate 100%. Clear?
Clear, sir.
Okay, now if you put this into a solution, then it will have certain pH, right? So as it is acidic buffer, its pH will be below 7. Okay, and as it is alkaline buffer, its pH is above 7. Clear to all?
Clear, sir.
Any confusion? Okay, so now look at how this buffer actually operates. That means how this buffer actually works. Okay, okay, so first of all, look at the composition of the acidic buffer. So we discussed that the acidic buffer composed of acetic acid and its corresponding salt, right?
Right, sir.
Okay, so as it is a weaker acid, that means it will not dissociate 100%. Okay, and when it will be dissociated, it will again return back to previous form. Okay, so the chances of the forward reaction is less, but chances of the backward reaction is high. Clear now?
Clear, sir.
Okay, and as the salt is stronger, corresponding salt is stronger, it will dissociate 100%. Okay, so now if you add a small amount of base, that means if you add a small amount of base, the base will donate hydroxyl group. So this hydroxyl group will react with the proton and it will form water. Okay, so same
Sir,
here.
could you please repeat?
Okay, so when you add base, so that means you are adding hydroxyl group. Okay, so this base will react with the proton. Okay, this base will actually react with the proton. So when it react with the proton, it will form water. Clear? Is it clear now, Tanvir?
And for second one, sir?
আচ্ছা, এইটা ক্লিয়ার কিনা সেটা বলো।
Ji, sir.
Okay, so when there will be no proton here, again it will dissociate. Okay, again it will dissociate and will neutralize another hydroxyl group. Clear?
Sir, could you please repeat again?
Okay, so when, yes, one by one, yes.
Yes, sir. Sir, repeat করার জন্য বলতেছি।
Okay, okay, so suppose you are adding hydroxyl group. Okay, this hydroxyl group will react with the proton to form water. Okay, so once it is depleted, another acid will dissociate to give another proton. Okay, and this proton will again react with another hydroxyl group. Clear now? So this process will going on until the neutralization of the OH group is done. Clear?
আচ্ছা এটা চলতেই থাকবে।
যখন তুমি সামান্য পরিমাণে অ্যাড করবে তখন এই প্রসেসটা চলতে থাকবে। ক্লিয়ার? ইয়েস অর্ণব?
স্যার এই অ্যাডিশনাল হাইড্রক্সিল গ্রুপটা কোত্থেকে আসতেছে?
We are adding it. Yes, this is coming from the base that we will add. Okay,
ওকে স্যার।
okay, so now think about that you are adding proton or acid. Okay, so when you add acid, it will donate the proton and this proton will react with this component. Okay, clear? It will react with the ethanol ion to form acetic acid again. So as it is a weaker acid, it will not dissociate that much, so that's how it will maintain the pH fairly constant. Clear?
So where will this H plus come from again?
this H plus coming from external sources when you will add acid, okay, into the buffer
Yes, sir.
solution.
Yes, sir. Yes, sir.
Any confusion, anyone? আচ্ছা, কারো কোনো কনফিউশন থাকলে বা বুঝতে সমস্যা হলে বলো। আচ্ছা ওকে, আচ্ছা ওকে, আমি আবার রিপিট করতেছি, হোয়াইট বোর্ডে ব্যাক করি। Okay, so we are talking about the acidic buffer, right? So acidic buffer, there will be an acid, okay. Okay, so this is the acid, and as it is a weaker acid, that means it will dissociate less, okay, clear? Okay, so when it dissociate, it will again return, it will again reassociate again and form again this acid, okay, clear? Okay, so the chances of the backward reaction is higher, clear this point? Okay, so now if you add a small amount of, suppose base you are adding, for example if you are adding sodium hydroxide, okay, so sodium hydroxide will donate OH group, right, and this OH group will react with this proton. After reacting, what it will form? It will form water, okay. Okay, so that's how it will try to maintain the pH, okay, try to reduce the pH, okay. And another its component is its salt, right? So as it is stronger, so it will dissociate 100%, okay. Okay. So now if you add some acid, for example if you are adding HCl, HCl will provide proton, right, and this proton will react with this, and after reacting it will form actually the acid, clear? So as it is a weaker acid, it will not dissociate 100%, okay, it will dissociate very little, so that's how it will try to resist the pH, okay. Is it clear now? Clear to all?
Yes, sir.
কারো কোনো কনফিউশন আছে? Any confusion? Okay, so now can anyone talk about the basic buffer? How it will work? Any one of you? Who can explain the mechanism of a basic buffer? It is same as the acidic buffer. Afsana meme,
স্যার
can you explain it?
স্যার এখানে বেসটা উইক থাকবে।
Yes.
স্যার আই হ্যাভ টু গো থ্রু দিস ওয়ান মোর টাইম, আই এম সরি।
Okay, okay. Okay, who can explain? It's simple, right? So in both the buffer, acidic, basic, in both the cases there is salt, right? So in the basic buffer, just the acid is replaced by a base. Clear?
স্যার বেসিক বাফারে বেসটা উইক থাকবে আর অ্যাসিডিক বাফারে অ্যাসিডটা উইক থাকবে,
Okay.
বোথ both সাইডেই সল্ট থাকবে and that will sorry মানে pH ভ্যালুটা চেঞ্জ করে দিবে।
Acha, okay. So suppose you are adding acid, okay, into a basic buffer solution. What will happen then?
Neutralize the solution.
স্যার নিউট্রালাইজ হয়ে যাবে।
Okay, how?
Mm, uh, acid proton will associated with hydroxyl group, so it will convert into H2O.
Okay, and if you add OH group, that means if you add base,
It will add it with a acid that's and neutralize it as an ammonium hydroxide.
okay, so
In
that
this case,
means I understand that your concept is not clear. Okay, okay, so look at the lecture slide. Okay, so the mechanism of the basic buffer is same as the acidic buffer. Okay, so in the basic buffer there will be a base and its corresponding salt. Okay, so as it is a weaker base, it will not dissociate 100%. Okay, clear? So the chances of the dissociation will be less, but that when it dissociate, chances of the reassociation again to form this base is higher. Clear? That means the chances of the backward reaction is higher. Okay, and as it is a stronger salt, so that means it will dissociate 100%. Is this concept clear to all?
Yes, sir.
Okay.
Yes sir.
Okay, so now if you are adding acid from your external source, the acid will donate the proton. Okay, and this proton will react with this OH group coming from this base. Okay, coming from this base, it will react with the hydroxyl group and it will form water. Okay, so that's how it will try to resist the pH. Okay, is it clear?
Yes, sir.
Okay,
yes, sir.
okay, so now if you are adding base from external sources, so the base will donate hydroxyl group and this hydroxyl group will react the ammonium ion that comes from the salt. Okay, and it will form ammonium hydroxide, that is this. Clear now? And as it is a weaker base, it will not dissociate more. So as it will not dissociate more, the pH will remain fairly constant. Clear?
Yes, sir.
কারো কোনো কনফিউশন আছে?
Can you please explain it again?
Okay, from where I will start? From the first or from just the adding of the acid or base?
After the addition, after what happens with, can you please explain it from the beginning?
Okay, okay, so I think then it's better to go to the whiteboard. Okay, so it's more clear. Okay, so in the basic buffer there will be a base, right? For example, it is a basic buffer component, it is a base. Okay, so the base will dissociate. So when it will dissociate, it will form ammonium ion and hydroxyl ion. Okay, and this reaction can go to backward as well. So as it is a weaker base, so the chances of the backward reaction is higher. Clear? Than the forward reaction. Okay, is it clear this point?
জি স্যার।
Okay, so now think about if you are adding acid from your external sources. Okay, acid, you are adding acid, so what will happen? Acid will donate proton. So when acid will donate proton, this proton will react this OH group and it will form water. Okay, clear?
Yes, sir.
It will form water. Okay, and another component of this buffer is its corresponding salt. Okay, so that is ammonium chloride. So as it is stronger, it will dissociate 100%. It will form ammonium ion and chloride ion. Okay, so now if you are adding base from the external sources, okay, so the base will donate OH group, right? The base will donate OH group, right? So if you are adding base, say for example, sorry, if you are adding, okay, so suppose I'm not sure why it is not writing. Okay, suppose you are adding base now, so the base will give this, right? And this will react with ammonium ion, and that means if it react with ammonium ion, it will form ammonium hydroxide. Clear now?
Yes, sir.
Yes, sir.
Any confusion now? কারো কোনো confusion?
No, sir, এখন cleared.
Okay, clear, thank you. Okay, so now we'll discuss some basic maths. Okay, first of all, do you know the log equation, log rules? Log AB equals to log A plus log B,
Yes, sir.
and
Yes, sir.
log A by B equals to minus log B by A. Do you know it? আমরা কি এটা জানি কিনা?
স্যার জানি বাট ভুলে গেছি একটু
আচ্ছা আচ্ছা, ওকে, ভুলে গেলে আমরা জাস্ট মনে করা ট্রাই করি। আচ্ছা, ওকে, ভুলে গেলে জাস্ট মনে করা ট্রাই করি, সিম্পল। সো ফার্স্ট অফ অল log AB, okay, log A into log B, okay, so log A into log B means log A plus log B,
Plus log B.
clear? And next rule is log A by B, okay, A by B equals to minus log B by A. So that means if you shift it, then you have to put a minus sign. Clear?
Yes, sir.
So simple. Okay, so this is a acid, right? So in the aqueous solution it will dissociate to form the proton, right? Clear? And this proton may react with water molecules to form hydronium ion, right?
Yes, sir.
Okay, so this is a acid dissociation constant, okay, Ka. Clear? So what does this constant means? This constant actually indicate how much acid is dissociating, okay, clear? Okay,
Yes, sir.
so K equals to the products at the right side, okay, the products at the right side, that means this one and this one, right, divided by the acid, okay, divided by the main reactant. Clear? আচ্ছা আমি খুব সিম্পলি
Sir, could you please repeat?
আচ্ছা আচ্ছা আমি খুব সিম্পলি বলার চেষ্টা করি। ধরো এখানে একটা কিছু আছে আর কি, ধরো এটা অ্যাসিড, হ্যাঁ, এই যে, ঠিক আছে, সো অ্যাসিড উইল ডোনেট প্রোটন, রাইট? Am I right or wrong? Okay,
Yes,
so
sir.
acid dissociation constant will be the dissociated part. Okay, dissociated part, the concentration of the dissociated part divided by the concentration of the acid. Clear now?
Yes, sir.
রিপিট করবেন
আচ্ছা ধরো এটা একটা অ্যাসিড সে ওকে সে দিস ইজ এ অ্যাসিড ওকে so acid will donate proton and here is the another component of this acid okay so acid dissociation constant will be equals to the concentration of the dissociated parts okay so the dissociated parts is proton and this part right so the concentration of this one and this one divided by the concentration of the total acid okay this is the acid clear simply
Yes, sir.
কারো কোনো কনফিউশন আছে এনি কনফিউশন okay so next another issue okay so suppose a acid is stronger okay so if the acid is stronger it will dissociate 100% right am I right or wrong
Yes, sir.
Yes, sir.
Yes, sir.
so if the acid is weaker it will not dissociate 100% right
Yes, sir.
Yes, sir.
okay and suppose it is a salt so suppose the corresponding salt here okay so it is this salt so the salt is stronger right so if the salt is stronger it will dissociate 100% right
Yes.
okay clear now if the salt is if the sorry I changed chloride it will be sodium okay so if the salt is stronger it will dissociate 100% right
Yes,
Yes,
sir.
sir.
okay so if the salt is stronger and it is dissociating 100% so then okay I'm deleting it again
স্যার সল্টের জন্য কি সেম ইকুয়েশন
okay okay this is a acid okay it is a weaker acid so that means it will dissociate less okay clear and if its corresponding salt is stronger so that means it will dissociate 100% right am I right or wrong
Right.
right okay so suppose you are here putting 100 of the weaker acid okay so here from here you may get here at maybe like 1 proton or 2 proton okay so if you get here 1 proton how many A minus ion you will get from here
1, sir.
1 okay and if you provide here 100 how many you will get here
Sir,
100,
100.
sir.
100 okay 100 and if you sum up total A it will be 101 right
Yes.
Yes, sir.
okay so that means this ion actually comes from mainly the salt right this ion
Yes, sir.
okay so this concentration actually will indicate the concentration of the salt okay in the buffer system clear it will indicate the concentration of the salt is this concept clear
Yes, sir.
okay so now if you put here like 100 acid you may get here 99 acid right 99 because one will dissociate right So 199 is very close, right?
Yes, sir.
Okay, so that means you can write this concentration as the concentration of the acid, okay, because it is not changing that much. Clear? Because it is almost same, right? So with the initial concentration, because 199 is almost same, right?
Yes, sir.
Okay, so if you understand this, then it is so simple. We are going to discuss an special equation. Okay, now this is very important. It is Henderson-Hasselbalch equation. The name comes from the scientist who discovered it. Okay. Okay. So think about a acidic buffer. So in the acidic buffer there will be an acid, right? Weaker acid, right? So the acid will dissociate.
Yes, sir.
Okay. So the acid dissociation constant K we can express the dissociated part divided by the acid, right? The concentration of the dissociated part divided by the concentration of the acid, right? Clear?
Clear.
Okay. So if we rearrange the equation, then we can write something like this. Okay. We are multiplying this by this. Okay. So KHA, and we can divide it by A. Clear? So then we can get concentration of the H plus equals to Ka into Ha divided by concentration of A minus. Clear?
Yes, sir.
Okay. So this A minus actually will indicate the salt, right? Because in the buffer it is actually coming from the salt, right?
Yes, sir.
And this one will indicate the acid. Clear? Okay, so now we can replace it is by acid and salt. Okay, is this point clear? এই পয়েন্টটা বুঝতে পারলাম কিনা
Sir,
সবাই?
could you please repeat the last line?
Okay, so from here you can see that this one will actually comes from the salt, right? And this one is actually
Yes,
the
sir.
concentration of the acid. Okay, so here we can write the salt, here we can write salt, and here we can write acid. Okay, clear now?
Yes, sir.
Okay, so just we written here acid and salt. Okay, is this point clear?
Yes, sir.
Okay, now if we take log in both side, we can take both sides same thing, right? So we can take log here and also log here. Clear? Is it clear?
Yes.
Yes, sir.
Okay, so then we can write log H plus. Okay, and here if we take log, we can write here log A into log B. Clear? So we know that log A into log B equals to log A plus log B, right?
Yes, sir.
Okay, so here it is log A and here this is log B. So now if we multiply both side by minus, then we will get something like this equation, right? We will get a minus sign here. Clear?
Yes, sir.
Okay, so minus log proton concentration means pH. Okay, negative logarithm of proton concentration means pH. Clear?
Yes, sir.
And negative logarithm of acid dissociation constant Ka equals to pKa. Okay, so then we can replace this. Okay, we can put here pH and here we can put pKa. Clear?
Yes, sir.
Okay, so now we know that log A by B equals to log minus log B by A, right?
Yes, sir.
Okay, that means if we replace it, we need to put a minus sign. So if we replace it and put a minus sign, this minus minus will be plus now. Okay, clear?
Yes, sir.
Yes, sir.
আচ্ছা, কারো কোনো কনফিউশন আছে এখন এই ইকুয়েশন বুঝতে? দিস ইকুয়েশন ইজ কল্ড হ্যান্ডারসন হ্যাসেলবার্গ ইকুয়েশন। ওকে, ডু ইউ হ্যাভ এনি কনফিউশন? Nazif, can you explain it from the first?
স্যার ট্রাই করতে পারি।
Okay, try.
স্যার এক্সপ্লেইন করব মানে এই ইকুয়েশনটা।
হ্যাঁ, একদম ফার্স্ট থেকে আমি যা যা বললাম একদম এখান থেকে তুমি এক্সপ্লেন করে এখানে যাবা। ওকে,
আচ্ছা স্যার, স্যার বাংলায় বলি।
যেহেতু ইন্টারন্যাশনাল আছে একজন, আমার মনে হয় যে ইংলিশে বললে ভালো হয়। আচ্ছা, হ্যাঁ।
It's fine. Here, this is this uh, equation related to buffer solution is called Henderson-Hasselbalch solution, equation, and here we will get to know about the pH value of the acid buffers. So for deriving the whole formula, we need to think about the acid, which is a weak acid, and it will not dissociate 100%, and it and suppose here the acid is Ha, and after dissociating it will donate some H plus ions and and some negative A minus ions, and later on if we calculate the dissociation rate of acid, then we will get that the concentration of H plus and A minus divided by the concentration of the weak acid, and then we will we will do some simple algebraic uh, calculations and derive the second line, and then we will ascend. Sir, next slide. And after that, as we know, the a the negative ion or anion has come from the salt of the salt related to the acid. Then we will replace it with the concentration of acid and concentration of salt by expressing it inside the third bracket, and later on we will take log on both sides. Then it will be log H plus is equals to log Ka. Ka means the dissociation rate of acid, and plus log acid divided by salt. Then we will multiply both sides by negative sign to get so that we can get the pH, as we know that pH is the negative logarithm of dissociated H plus ions. So minus log H plus will be equal to minus log Ka minus log acid divided by salt. And then lastly, we will replace the terms pH and pKa with their related parts, and then the whole equation comes, which is pH is equals to pKa plus log divided by salt divided by acid. And here the negative sign has changed because we made the fraction upside down. Firstly, acid was the in here salt was the denominator, and after making it a positive sign, it has been turned out. So yes, sir.
Okay, Nazif, thank you. Okay.
Thank you.
Shitol, can you explain it now for the basic buffer, the same equation?
Okay, sir. I will try. When we take the basic solution, the base is weak and salt is stronger, and salt can dissociate, but due to weak base, it cannot, and it dissociates into B plus and hydroxide ion. And when we take the Kb, it gives the product concentration of dissociated product upon dissociated base.
Okay, so the Kb is here, base dissociation constant. Okay.
Okay, sir.
Okay. Next, explain.
And
Okay.
when we rearrange the that equation, we will get that first equation, OH hydroxide ion equals to Kb BOH by B plus. So next slide, please. And as and we can take that as base by salt, as it is the react.
So this one is actually the base, and this one is
Yes,
actually
yes,
coming from the salt, right?
salt. Yes, sir.
Okay.
And when we take log on both sides, we will get this equation of log hydroxide ion equals to log Kb plus log base by salt, because we take Kb and base by salt as A and B, so it will become log Kb plus log base by salt. And when we multiply both sides by negative sign, it will be minus log hydroxide ion, so we can get PS from here. And when we take, and for other here, it will be minus log Kb minus log base by salt. And for down here, minus log base by salt. So I'm not good in explanation.
Okay. 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 So what happened? We taken here a minus sign. Okay. So we know that minus log OH concentration is actually the POH. Okay. And minus log Kb equals to pKb. Clear? So we replace these values here. Okay. And now if we want to shift these two things, then what we need to do, we need to put a minus sign here, right? So this minus sign will then, minus minus will be then plus. Okay. So then we can replace it salt by base. Clear?
Yes, sir.
Okay. Do you have any confusion? কারো কোনো confusion আছে? Anyone?
লাস্ট লাইনটা আরেকবার একটু যদি এক্সপ্লেন করতেন।
Okay. Okay. So here we multiplied both the side by minus. Okay. So if we multiply both the side by minus, so we can put here just minus signs. Okay. And we know that minus log hydroxyl ion concentration equals to POH. Okay. Minus log hydroxyl ion concentration means POH. Clear? And minus log Kb equals to pKb. So then we replace this value here in this equation. Clear? So this is done. Okay. And we know that log A by B equals to minus log B by A. Okay. So that means we can shift this, we can shift their positions. Okay. So when we shift their position, we need to put a minus sign. So when we put a minus sign, this minus sign will, this minus sign and another minus sign will be then plus, right? Because we know that minus minus means plus, right? So here we can put the plus sign, and then we can replace this, replace their position. Okay. Clear?
Yes.
Is it clear to all now?
Yes, sir.
আচ্ছা, যদি কারো কাছে এখনো কনফিউজিং মনে হয় তাহলে ফ্রিলি বলো, আমি তাহলে আবার এক্সপ্লেন করব।
স্যার এখানে আমাদের পিওএইচ এর জায়গায় পিএইচ এর মান বের করার কথা না, লাইক পিও 14 মাইনাস পিওএইচ করার কথা না?
Okay, so here it is POH because here you have taken hydroxyl ion, right?
না স্যার, আমি বলছি যে 14 মাইনাস পিওএইচ করলে তো পিএইচ এর মান পাওয়া যায় স্যার, এখানে এই কাজটা করার কথা না?
আচ্ছা, 14 মাইনাস পিএইচ হবে কিনা সেটা আমরা আসতেছি একটু পরে, ঠিক আছে?
ওকে
Okay, just make sure that you understand this point. Okay, this equation and this equation.
जी सर.
Okay, so we know that water can form hydronium ion, right? Water is the amphoteric compound, it can donate proton, right?
Yes, sir.
Yes,
Okay,
sir.
so suppose here is two water molecule. Okay, so one water molecule is donating proton. Okay, so this proton will react with another water molecule to form hydronium ion. Okay, and this is the OH group. Clear? Is it clear?
Yes, sir.
Okay, so now we can write water dissociation constant equals to this part, right? Divided by water. Clear?
Yes, sir.
Okay, so when we write the water dissociation constant Kw, we actually omit the denominator water. Okay, clear? Because why we exclude it? Because its concentration remain the same almost. Okay, so that's why we don't consider this thing into account. Clear? Is it clear now?
Sir, can you make the slides full screen?
Acha, full screen. Acha, okay, acha. Sorry. আচ্ছা আমি ফার্স্ট থেকে আবার এক্সপ্লেন করি ওকে so here two water molecules are reacting we know that water can donate proton right it is an amphoteric compound right it can act as both acid and base okay so suppose one water molecule is donating a proton and this proton is accepting by another water molecule so it will form the hydronium ion okay and this is the rest of the component after donating the proton okay so that means it is the OH group okay so now we know the water dissociation constant equals to this part right the concentration of the hydronium ion OH into OH ion divided by water right water concentration is it clear
Yes, sir.
okay so as the water concentration doesn't change so that's why we exclude the water concentration from the denominator clear so just we can write this clear now
স্যার বুঝিনি এখন
আচ্ছা ওয়াটার কনসেন্ট্রেশনটা আমরা যখন ওয়াটার ডিসোসিয়েশন কনসেন্ট্রের মান বের করি তখন ওয়াটারের কনসেন্ট্রেশনটা আমরা হিসাবে আনি না ক্লিয়ার কথাটা
আচ্ছা স্যার
আচ্ছা কেন নিয়ে আসা হয় না কারণ এটা কনস্ট্যান্ট থাকে ওকে ক্লিয়ার
ওকে
ওকে সো ওয়াটার ডিসোসিয়েশন কনস্ট্যান্টের একটা ভ্যালু আছে ওকে at 298 Kelvin temperature the value is 10 to the power minus 14 clear clear সবার কাছে
Yes, sir.
okay so then we can replace this by this value right
Yes, sir.
okay now if we take log in both the side then we can write something like this right
Yes, sir.
okay so as it is log 10 base so then it will subtract then we'll write here minus 14 clear
Yes, sir.
okay now if we multiply both the side by negative minus sign so then it will be minus log hydronium ion minus log OH ion right and minus minus there will be plus 14 right clear so this hydronium ion actually indicate the proton right so this hydronium ion or the proton concentration it is same okay so hydronium ion concentration equals to the pH clear
Yes, sir.
Okay, so then we
Yes,
can
sir.
replace here pH, and here we can replace by POH, and here it is the 14. Okay, clear now?
Okay, sir. Yes,
Okay,
sir.
so that means pH equals to 14 minus POH. Okay, clear to all? সবাই কি বুঝতে পারলাম? লামিশা ইবনাত আলী,
Yes, sir.
did you understand it?
Hello.
Yes,
Yes, sir. Like
বুঝতে
I
পারছো
just
কি
have
না?
to go through it. জি স্যার বুঝতে পেরেছি এটা তারপরও একটু go through করতে হবে
আচ্ছা, কোথাকার কনফিউশনের জন্য তোমাকে গো থ্রু করতে হবে সেটা আমাকে বলো, মানে তুমি কোথায় কনফিউজ সেটা বলো।
স্যার আমি log and I don't know I just get really nervous যখন আমার maths এর কিছু আসে so এই কারণে আমার go through করতে হবে
আচ্ছা আচ্ছা, বুঝতে পারছি কথা। আচ্ছা আচ্ছা, ম্যাথ আসলে যদি আমরা ভয় পেয়ে যাই, হ্যাঁ, আগে তো আমাদের জানতে হবে যে ম্যাথটা আসলে ইজি নাকি কঠিন, ঠিক না? ম্যাথ যদি ইজি হয় তাও যদি আমরা ভয় পাই,